Okay, so on pages E3 and E4, what I want you to think about here is another way of memorizing. If besides using SOHCAHTOA, now because we've transposed these triangles onto the coordinate plane, I want you to think about how we can use not just opposites and adjacents and hypotenuses, but x and y, and then r, which stands for the radius of that circle. Okay, so I want you to think about that for a second. If you look at this particular triangle, this would be a triangle that would be, technically would be in quadrant 2. We're going to use this angle as our reference. So I want you to think about, we can use SOHCAHTOA to then help us think about whether we have x's and y's and r's, what the ratio is with respect to our x's and y's and r's. So if you think about our sine value, it's opposite over hypotenuse for that ratio. But I want you to think visually about what that would be if we were on the coordinate plane. So if we were at this point out here, and we have this particular, so we have this point out here, x, y. Actually, in this case, it would be a negative x value, right? That doesn't really matter. We just want to know whether it's x or y or whatever. But our sine ratio corresponds to opposite over hypotenuse. So with respect to x's and y's and r's, what does that correspond to? The opposite side, is that x or y or r?
Y.
This is our y value, right? The distance that we're going up from the coordinate plane, from the x-axis. We're going up that distance y. Our adjacent corresponds to the x, and then this is our r. I'm sorry, what?
Is that negative x?
Yeah, in this case, in that quadrant, it would be a negative value, you're right. But in general, we just want to remember that what that's telling us then for sine, if we're doing opposite over hypotenuse, we just want to remember that it's the y value over the r. Right? The r is our radius, our hypotenuse, and that's always going to be, on the unit circle, it's always equal to 1, right? Think about our cosine. Our cosine we know is adjacent over hypotenuse. If we think about what that corresponds to on our in our coordinate plane on those lines, it's x over r. And guys, think about this. The reason why the unit circle is so convenient is because our r value is just equal to 1. So that's why to find our cosine value, we just have to focus on the x. And to find the sine value, we just have to focus on the y, because our r is equal to 1. Denominator would just be equal to 1. Okay, what about tangent? We know tangent is opposite over adjacent. And so for tangent, we know we're going to do y over x. Okay. So then similarly, we're going to go ahead and put this in here. We're not going to use it a whole lot. Actually, we are going to use it in this next little bit. So for cosecant, with respect to x's and y's and r's, it's going to be r over y. For secant, it's going to be r over x. And for cotangent, it's going to be x over y. So once again, for me, I don't memorize these per se, but I do know that cosecant is the reciprocal of sine. So it means I know I'm going to flip the sine value. For secant, I don't memorize r over x, but I do memorize that secant is the reciprocal of cosine. So I'm going to look at the x coordinate, which corresponds to the cosine, and I'm just going to flip it. And then similarly for the cotangent, I'm going to look at the tangent. I'm going to think y over x. Actually, on that one, I do remember I just go x over y instead of y over x, because I'm just flipping it. Okay? All right, let's use that info, because here's what happens. If we have any triangle in any of the quadrants, then we can kind of think SOHCAHTOA. But where that kind of falls apart is if we're looking at a quadrantal angle, so a 90-degree angle, or a 0 degree, or a 180, or a 270, or a 360. So I want you to think about this. So we've got 0 degrees, 90 degrees, or 180 over here, or 270 here. This can also be considered 360. In this case, we can think of this as like basically any radius, any distance that we want out. We're not gonna, if the points are right on the quadrants, then our triangle is basically fallen or collapsed onto itself. So all we're really looking at is what's the radius. Okay, so if we just choose a number, Winston.
No, would the 180 technically be 0 degrees?
Say that again?
Would the 180 degrees technically be 0 degrees?
Sorry,
like
I still.
360 and 0 degrees. Wouldn't the 180 also have, like, be considered like a 0 degree or no?
No, 0 degrees just means we're starting in the standard position, but we're not rotating. The 360 means we're rotating all the way around, but we're still ending up in that same spot.
Okay.
So, okay, glad you asked that. All right, let's think about coordinate points here. If we go out some distance, so in this case, just for convenience sake, since we've been talking about the unit circle, let's just go on out a distance 1. So I want you to think about the coordinates here at 0 degrees or 0 pi. So if we go out here, we're at 1, 0. If we go up here, we're at 0, 1. Over here, we're at -1, 0. And down here, we're at 0, -1. So we can use our ratios, our x's and y's and r's now to figure out the quadrantal angles as well. Okay? So in other words, first thing we need to think about is we're looking for a sine value, and we know sine is y over r. Or r, in this case, is equal to 1. So really, it's just y. So what's the sine value at 90 degrees? So the sine of 90 degrees is what? 1. There you go. Okay, so the cosine at 180 degrees. The cosine, we know we want to look at the x value. Our ratio is x over r, but r is just equal to 1, so it's really just the x. And the x value at 180 degrees is -1. Okay. All right, tangent we know is y over x. And we're looking at 270 degrees, so what is that equal to? Undefined. Good, Sloan, that's right. And then the cosecant of 0. We haven't talked about these. I'm trying to decide. Let's hold off on those. We'll deal with those later. So let's skip. Let's go to the cosine of 90 degrees. So x over r. Brady, did you find where we were? Yeah. Okay. In other words, just x, because r is just equal to 1. So yeah, Chris, cosine of 90 degrees is just 0. Whoops, not 0 degrees. And then the tangent of 180. So we know we're doing y over x for the tangent of 180. So that's 0 over -1, or just 0. And then the cosine of 360. So cosine we know is x over r, or we're going to just look at the x. In this case, that means it is 1. So I want you to notice it's kind of a special pattern that happens with the quadrantal angles, your 0, 90, 180, 270, 360, or your 0, your pi over 2. This could have been in radians also. I didn't do this in radians, but it could have been 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi for any of those quadrantal angles. Notice what the answers end up looking like. they're either a 1 or a -1 or a 0 or an undefined. Okay, and that's going to be the case for any of the quadrantal angles that you're going to have those types of answers. Okay, Ryan?
When are we gonna have like our next quiz or test?
You've got a memorization quiz on day 3 this week where you're going to have to fill in the whole unit circle and then answer some questions similar to what you did on that Quizlet.
How many points is that?
We haven't finished putting it together yet, so I'm not sure.
Okay.
Good question.